All right, we are in Cal 1 and we're looking at some indefinite. And well, actually, we're not doing indefinite integration anymore. We're finding particular solutions, but this is the section, this is what it's called. A ball is thrown upward at an initial velocity of 45 feet per second from an initial height of 5 feet. Now, of course, we're neglecting air resistance, and we're saying that the ball is going straight up and then coming straight back down again. What we're going to want to do is find the position function. So in a previous problem, we started with the second derivative. We were given some conditions with the first derivative, and then we found its position function. And that's all we're doing, except we're just kind of adding an application here to that. All right. I'm using these English units, feet per second, but you could use meters per second if you wish and convert 32 feet to meters. I think it's like approximated to 9.8. Anyway, if you wish, if you want to do that. All right. So anyway, here's the given information right here, and this is what we're going to be working with. So rewriting our given information. So let me just draw a picture here. We got here's the ground, let's say. Okay. And we're going to go up 5 feet. So if you could imagine a ball being shot out of a cannon and it's approximately 5 feet from the ground, or maybe you are going to release this ball and throw it straight up in the air. The ball is going to go straight up and then it's going to come straight back down again. And here's something interesting. It will reach a maximum height. You might want to try to find that maximum height. And then we could find things like how long did it take for the ball to hit the ground after its initial release. So there's quite a few things we can find here. But we want to construct this position function. And of course, we're given the second derivative. So to find h prime of t, we're going to take the integral of negative 32 and so we have negative 32t plus c is our h prime of t. But now we've got some conditions here, 0, 45. So if we set it equal to 45, plug 0 in for t, negative 32, 0 plus c. Therefore, c becomes 45. And so now we have k, or not k, h prime of t is equal to negative 32t plus 45. Now we want to take the integral of this that's dt, and this is going to be our position function, actually, h of t. And let's go back up here. This is when h is 0 is equal to 5. Okay. So we have negative 32 t squared over 2 plus 45t plus c. And therefore we have h of t is equal to. And now what we're going to want to do is take 2 divided into 32, negative 16t squared plus 45t plus c. We're just simplifying it down a little bit. So remember, at time 0, h of t is equal to 5 feet. So we set it equal to 5, plugging 0 in up here, and so we end up getting c is equal to 5. Therefore, our position function h of t is equal to negative 16 t squared